Welcome to the CFE Media and Technology Education Session, Standards-Based Interoperability for Digital Transformation in Asset Lifecycle Management. I'm your moderator, Mark T. Hosky, with CFE Media and Technology. In keeping with our CEP policy, please take some time to read the quality assurance slide. This session is designed for industrial IT professionals, engineers, and maintenance and reliability professionals who are involved in designing, developing, and implementing digitally transformed asset lifecycle management solutions. Here is a list of the learning objectives for today. For a seamless online experience, here are some tips. You may download the presentation on the left side of the screen below the session's agenda. If you'd like to take notes within the session, click on the left panel labeled Notes to do so. The session is available on demand if you need to come back at any time. Please remember the session will be made live at 10 a.m. Central Daylight Time, 11 a.m. Eastern Daylight Time, with the Q&A starting approximately 10:45 and 11:45 Eastern, or immediately after the presentation ends if it runs a little longer than 45 minutes. An industry expert will answer viewer questions, and those answers will be archived with the session. Continuing education credit is available by passing the final exam at the end of the session. Here's some information about obtaining approved PDHs for today's session. Today's speaker is Alan T. Johnston, MIMOSA President and Convenor of ISO TC 184 Working Group 6, Interoperability for Asset-Intensive Industries. I'm your moderator, Mark T. Hosky, Content Manager, CFE Media and Technology. Alan Johnston has more than 40 years of information architecture, systems analysis, systems integration, and software development experience, with a special focus on the interoperability and digital transformation for lifecycle asset management and critical infrastructure management. He has led many enterprise integration projects in asset-intensive industries and was a program manager at the U.S. Army Aviation and Missile Research Design and Engineering Center Software Engineering Directorate at Redstone Arsenal for 6 years. Alan currently serves as MIMOSA President, a voting member of the ISA 95 Committee, and convener for ISO TC 184 Working Group 6, with the scope of asset-intensive industry interoperability. Alan, welcome, and please go ahead.
Hello, thank you for joining today, and I also want to express my appreciation to CFE Media and CFE EDU for allowing us to do this course. So this is a quick topical outline of everything I'm hoping to talk about. And the just in terms of the flow, starting with what's the problem we're trying to solve, closing the interdependencies gap, talking some about the formal standards then that are included in this activity, both the international and industry standards, and then the Q&A session at the end. So hopefully we'll be able to get through this material. There is quite a bit of it. And then, of course, there's links available for your further reading and understanding. First, what are MIMOSA and Open O&M? Since I'm president of MIMOSA, so MIMOSA is a 501c6, not-for-profit industry association. We're actually a standards developing organization at the industry level, and we have a formal relationship with ANSI, where we work with them on ISO standards. And then the organization itself also is funded by its members, which can include operators, suppliers of all types, university-affiliated research centers, and others. And ultimately, we provide a safe harbor location for people from a variety of industry sectors to work together with each other to do industry level standardization before we promulgate those standards to ISO. The Open O&M initiative was formed by a multi-party MOU, includes MIMOSA and ISA, MESA, OAGI, and OPC Foundation, where we got together and said, okay, if we wanted people to use our standards for interoperability, we probably needed to interoperate much more ourselves. We also developed some of the standards together and specifications together, which are published on openon.org. MIMOSA itself does focus on standardization and digital transformation for asset lifecycle management related topical areas and covering platforms, plants, and facilities. A word on critical infrastructure interdependencies. This is a seminal work that was done about 20 years ago. The gentlemen involved, Rinaldi and Perenboom and Kelly, have gone on to do other interesting things in their lives, in a lot of cases associated with Department of Energy. But this basic analysis was done originally looking at various major areas of critical infrastructure and how interdependent they were, and even doing the mathematical modeling on how fast various sectors fail, if any of the sectors fail, or if any part of any of those sectors fail. Therefore, it's a very broadly referred to document by many others, and I'm going to show you a couple more after this, which they reference this document in their chain of dependencies. So this was actually NIST picking up on that very same drawing. So this is content identical to the previous one. It's just now drawn in scalable graphics, some interesting color combinations, but it's examining the very same topical area. And again, this is jumping all the way forward to 2015, where once again, the foundation was the same starting point. And then we roll forward to this work done by FEMA and Department of Homeland Security, which once again, in its chain of dependencies, points back to the other two documents, where now they're detailing in some specifics here about infrastructure and resiliency. But this work was done, like I said, even at the level of mathematical modeling in the first documents, the first article. So these are really excellent, places to go look and get a solid foundation. The bottom line is, because they're interdependent and everything fails if anything fails, unless it's kept from doing so, it's really important that we started thinking this way and then addressing these problems. The critical infrastructure sectors, just in terms of a topical list, this is from PPD 21 in the Obama administration. And essentially, again, these are all the various sectors that the US government has identified. Other nations do similar things. A pretty significant number of these sectors actually have especially close working relationships with each other. And a lot of them share engineering methods, as well as a lot of commonalities in terms of their supply chains being tightly interrelated with each other. That actually, again, sort of keeps adding to the problem space, which we're trying to address with some solutions. So ultimately, if one can model the various aspects of critical infrastructure from an engineering and design point of view, so that we're dealing with the processes as well as the system models, as well as the component models, then there actually gets to be the potential for saying we could take a very standard approach to also adding in the business process models, and ultimately having risk models that could sit on top of these standards and give us an integrated view of risk. Now, it turns out that many, many people are interested in understanding the risk in critical infrastructure. Some of these people are in our own public sector, but then many industry participants, as well as just the public at large, realizes that there would be some benefit to looking at this, both through what has happened with issues like with pipelines, where we start to realize interdependencies. And then many people are now seeing this with COVID-19 and what has happened to supply chains. So the ability to look at things in a holistic manner and actually do this modeling and have adequate standardization to allow interoperability would then allow the analytics to sit on top of all this and look at things in terms of, what's the real risk at an enterprise level? What's the real risk then at perhaps a national or regional level? And understand then how we can start doing risk management and risk mitigation associated with this. Another interesting aspect of this is most people have heard of the Five Eyes nations. There's a corollary to that called the Critical Five. And the Critical Five actually consist of the Crown Colony nations. They're exactly the same as the Five Eyes nations, and for similar reasons. We have special relationships of trust established with each other. And those special relationships of trust mean that we can share additional information with each other to hopefully help each other manage our critical infrastructure. And this reflects the acknowledgement that the interdependencies don't end at our borders, that absolutely, as we've discovered in COVID-19, that we are a world with far-flung supply chains. In this case, we're at least saying amongst these five nations, we're going to work with each other to the greatest practical degree to help ensure each other's critical infrastructure and the resiliency thereof. So now that we've sort of looked at a problem space, how do we close these gaps? There are many other things we could have looked at dealing with economic efficiency and timeliness of work being done. That also results from many of the gaps in the various industry sectors being done in proprietary ways. So ultimately, historically, we have dealt with modularity, interoperability, and standardization. And the standardizations piece then is what I'm going to try to speak about today in a pragmatic sense, where, again, we bring things together based on industry working together in a cooperative manner and identifying prioritized ways of actually sharing their problems and then hopefully sharing their solutions. And this takes into account now some of the new buzzword technology, like digital ecosystems with digital twins, which can then interoperate with each other across the asset lifecycle, assuming we share the correct standards. Industrial revolution phases have always had certain commonalities. So as different as they've been and as long as some of the phases have spanned, it turns out that there was generally some new sort of technology that stimulates the beginning of one of these phases, but then ultimately to gain business efficiency and operating efficiency, each time that we've done things, starting all the way back with the age of steam and Industry 1.0, we had to come up with things like standard rail gauge. We also had to come up with things as simple as standard screw threads, believe it or not, because until we did that, everybody building locomotives and building any sort of steam-powered equipment, they had people having to sit in the back shop someplace making custom screws to tie everything together and doing custom screw threading. Obviously, that was not very productive. Once we got into electrification and early aspects of mechanization, again, we started seeing another great need to agree on standardization. Started off, everyone's familiar with the wars about DC versus AC, different frequencies, different voltages. We've pretty quickly got it down, at least in different regions of the world, to where we did have broad agreement on AC and frequencies and voltages, and then also offering plug compatibility at the level of where you plug into these things, unless you're in the really heavy end of it in terms of ultra high voltage and bandwidth, where there's still some customization. But for the vast majority of the world, we have now switching power supplies and plugs that allow us to do what we need to do. Then as we got on into Industry 3.0, we saw more and more of this happening. Actually now with many also other mechanical standards, things really allowing the development of robotics, ever more sophisticated industrial equipment and devices out there. And now we've moved into what they're calling Industry 4.0. There's still some disagreement on exactly what it is, because it's like a lot of terms that sort of gets defined over time. But ultimately, it is the upward integration of everything that's happened previously. Everything becomes connected to everything. And we also now have to have artificial intelligence playing a significant role in this. So we've, again, gone through the standards at the physical level, the mechanical level, the electric and utility level, telephony standards, intermodal transport. We're now at the point we really need sufficient standardization on industrial IS, IM, and IT to allow us to move forward with modularity, interoperability, and standardization that's applicable to this same space as well in Industry 4.0. All right, there are many standards groups that are involved in these activities that are related to this space. We don't claim this is an all-inclusive list, but this is a reasonable representation of the key groups, particularly the industry standards developing organizations and associations that have relationships with each other and have agreed to work together in various aspects of this. I would draw your attention in particular to this group in the middle, where we're coming down, where MIMOSA, ISA, MESA, OAGI, and OPC once again got together to form the Open O&M initiative. Again, that was done almost 15 years ago. This group of standards bodies working together with each other have been able to drive out the industrial specification that we're talking about, which is the Open Industrial Interoperability Ecosystem Spec. It's a composite. It's a series of specifications that are used together in a repeatable and scalable way, where everything is supplier neutral and everything is in fact standardized, completely open. Other groups have provided a lot of input into this process, where we have MOUs and they're actually providing best practices or good practices in various discipline areas, where these things are getting folded together for digital purposes, actually in the track coming down the middle. In turn, once we get the industry level work done, there is a pilot that's run. In this case, it's called the OIIE OGI, which stood for Oil and Gas Interoperability pilot. And that pilot is actually formally written in to ISO 18101 as the way that it is built in the future. So it's sort of interesting to have a industry pilot that is documented directly into an ISO standard that gives us this ability to develop, validate, and prove that we're doing the standards the correct way by taking them through the pilot before we publish an ISO. So when we actually publish an ISO, we're pretty comfortable we're publishing things that are fit for purpose. This working group, again, is interoperability for asset-intensive industries. It does develop 18101 as it's being then published by ISO. It works with many other ISO and IEC groups. So again, we're trying to avoid reinventing wheels here. We are trying to leverage, federate, and enhance where needed other pre-existing standards that we need to achieve standards-based interoperability. This is an example of a key standard that's our key specification that's done first in the Open O&M initiative, and then very much shared, particularly between MIMOSA and ISA that I mentioned previously. This is actually an ISA 95 slide for people who are familiar with the ISA 95 committee. So many standards have been developed over the years that only take you to the level of concepts, and you can implement them any way that you want. And you'll sort of be doing things that are similar, but they won't interoperate with each other. And the idea under the Open O&M initiative, and then the work we're doing together on the OIIE, is that we now add in the additional level of detail that's in fact required, so that you can ensure that any two implementations will interoperate with each other, and it can actually be conformance tested then in the interoperability pilot and the associated test bed. So again, it's very good to have this cooperation where we can drive this out, including not only people from the asset lifecycle management community, but people also from the operations management community, working on these things together with each other so that everyone can benefit. And this is actually published then on the Open O&M website, which does happen to be managed by MIMOSA, but it's all very collaborative in terms of the underlying documentation. And this is getting updated even now to the 2.1 version of the spec. So as our pilot iterates and we keep seeing new requirements coming in, that will cause many of the individual parts of the specification to be incrementally updated and once again validated with actual implementations thereof. This is another view of what we're talking about that includes a pretty good composite overview of the standards that are related to digital ecosystems and digital twins. This is a view from ISO IEC Joint Working Group 21, Task Force 8 for digital twin. And this in particular came out of the task force report in the plenary last November. So if you look at the outer belt here, it's the industry standards and the industry standards associations. And you'll notice the OIIE, MIMOSA, and Open O&M all included here along with MESA, BETA, and MML. You'll also see over here other standards you may be quite familiar with, like OPC-UA and others as well, Industrial Information Consortia, et cetera. If we come in one loop, or one circle, concentric circle, or concentric oval, you'll see now also we have the ISO and IEC standards groups that are involved at the TC and subcommittee level. And we also call out individual standards that are directly related and relevant to this. So this is 62264, which is an IEC ISO standard, which is essentially the instantiation at ISO IEC ISA 95 standard. Then we have ISO 18101, which I'm going to be giving you more description of as we go here. And that's the outgrowth, again, of the OIIE, that those are brought together at the ISO level through the piloting process that I described earlier. And then ISO level technical reports being generated that go ahead and drive out the future build here. I convene Working Group 6, which is right here. And it's interesting that this is a working group directly under a technical committee. Generally speaking, you have subcommittees. So you see subcommittee 1, subcommittee 4, subcommittee 5 under technical committees and working groups under them. But because we're trying to federate many standards together with each other rather than reinvent them, this working group for interoperability operates directly at the technical committee level and then liaises heavily, broadly across other groups, including, again, like ISO IEC Joint Working Group 21. Conceptually, what we're trying to enable here is connecting dots. So if you think there are these critical infrastructure interdependencies, which there are, that again, they've been modeled for years, the idea is how do we start closing the gaps in those? Well, even within a single industry, it turns out that it's very difficult to close all the gaps in the supply chains. Again, that's showing up a lot now due to COVID-19. But more broadly, again, we have this idea of an industry cluster. It was originally called an industry business cluster. The idea was developed some 20 years ago. And people are now going, okay, well, we're announcing clusters all over the world of various types. In particular, there's a lot of energy clusters, but then there are other industries doing the same thing. This approach in terms of IS, IM, and IT really allows clusters to be brought together with each other based on standards that are mutually beneficial and agnostic to the particular application systems and software that a given industry participant might be using. So you can have operator 1, operator 2, operator 3. There could be more. This is an arbitrary, fairly small example. That operator could have regional operations as well. They could then share certain things also with other operators, and there can be any combination of suppliers in here of specific types like EPC firms involved in engineering, procurement, and construction, as well as any other type of supplier. And rather than requiring that these be hub and spoke or just network point-to-point chaos, you can actually designate then a cluster manager. This is a major leap forward to be able to start to do this and say, okay, we, this group of participants in this cluster, delegate the authority to manage the cluster to somebody. It might be one of the operators, or it could be anybody else that the people in the cluster delegate that authority to. And oh, by the way, what is delegated could be taken back if somebody does a really lousy job of it. So the bottom line is you're not getting locked into anything. You're not getting locked into hub and spoke or somebody that owns the hub and everybody has to put everything in the hub. And then you discover that there's 100 other hubs that you also have to put everything in. This builds on top of the internet, which we obviously, one of the major drivers was let's avoid hub and spoke because of a whole series of problems, including cyber risk associated with that architecture. So we believe this is a very useful paradigm shift that is now able to start to take place based on standards. So in order to actually implement these clusters, we need the ability to have a set of standards and specifications that are common and shared with our industry participants. And these are the additional things that frequently are not included in concept standards, but are always included when we are doing enterprise integration or inter-enterprise integration scale activities. So it turns out to be things like standard information service bus specifications with standard APIs, standard message models, standard reference data, standard directories, standard registers. Again, these are things that those of us who've done large scale enterprise integration know we build them over and over again, often project by project, or best case enterprise by enterprise. Generally speaking, they're built very similarly, but just enough different that they won't interoperate automatically. And then we have to sustain these things in perpetuity as individual code bases. And this turns out to be really expensive and really fragile, and it doesn't get us to this modular, reusable, interoperable approach based on standards that we need to go to in order to gain the economic efficiencies. So we then, need to move on from that to the next phase of what we can do to solve problems together in the standards themselves. So I'm going to talk more about the OIIE and ISO 18101. This is initially done as a TS. So you notice it's ISO TS 18101 Part 1. There's also an IS. There's also a TR. A TS sits right in the middle. A TS has all the legal enforcement of an IS, but you update it every 3 years. And in any area that's changing as rapidly as these, TS is about all we want right now. TRs are done as interim type work where it's not legally enforceable, but generally those are our input documents that we then use to elevate and create TSs. So I'm going to take you through a set of text here as well to help you understand and see some of this coming back for people that understand things better in a textual form. Then we'll look at figures that are associated with it and keep moving forward. So the interoperability definition. Okay, so we're talking a lot about interoperability. What the heck is that? This is a well-developed definition that goes back, came out of originally the system engineering community. It's pretty simple. This is the formal definition. It's just these 2 lines. And it's simple but powerful. And that's always good when you can have something like that. The history on it is down here. There's one minor change that was made since 2009 that we updated when we were doing this work in 2019. We changed the word respective in the original text to specified, and that's right here. And that was just to make it really clear that the key thing about interoperability is two or more entities working together to perform their specified task. We just wanted to eliminate any ambiguity on that. But ultimately, they're exchanging items in accordance with a set of rules, and this allows complex systems of systems to be built, whether they're physical or digital. And you notice when we get down here in the note 2, the items to be exchanged could include information being the first one, but it can also be many, many other things that are actually associated, sorry about that, that are associated with any system of systems needing to work together with each other. So again, short definition that's extremely inclusive and very powerful. The scope of ISO TS 18101 is also important for us because it, again, sets a context for everything that we're doing. So again, it is very much architecturally oriented. Again, also building out the basis for a supplier neutral industrial digital ecosystem. And this document actually then gives the guidance for architectures applicable to oil and gas, petrochemical, power generation, public utilities, and other asset intensive industries, which is a large group of those critical infrastructure industries. Now, again, this is the first also ISO or IEC document to actually provide a specification for a supplier neutral industrial digital ecosystem, which we believe is an important step forward. Lots of people have talked about it, used the language, but this is the first time we've succeeded in getting something at the ISO level as well then as a logical way to build this out. And that logical way to build this out is, again, documented in the forward. And so particularly looking at the language in yellow here, the future parts of ISO 18101 will be developed, okay? So that's fairly specific language, including the sets of industry developed use cases. This describes the process, but ultimately what it's describing is it's all based on the OIIE, and then it's all done through the OIIE OGI pilot, or again, as I said earlier, that's Open Industrial Interoperability Ecosystem Oil and Gas Interoperability Pilot. We started out with oil and gas assets, but essentially it was a fractionating tower. Many people have fractionating towers, and there are now starting to be many other asset classes added to the piloting that have essentially, nothing to do or are certainly not oil and gas specific, even some transport sector related things. So over time, this will keep iterating, and we'll probably wind up changing the name so it isn't just OGI, but it is what it is right now in the ISO document until we update it again. All right, so I've said asset lifecycle as well. So what does that look like? This is the full asset lifecycle. And again, it starts all the way at the beginning with product design and OEM type work. You're building instances of these products. We have, again, then a capital project starts at some point where you are upwardly integrating many products and devices into a capital project where you're doing the engineering, then detail engineering and design. By the time you get to the detail engineering and design, you're developing a lot of schema that go along and support what you laid out initially in your process engineering and simulation. So those schema would be things like your piping and instrumentation diagrams. Again, many of those are still going to be 2Ds for a long time to come. They can also be done with 3Ds if people have it. The ISOs that are out there and the various other things that you need, like line list, et cetera, that engineers and specialists in the various skilled crafts all actually use. As that is done, and as you actually get to the feed or pre-feed, then you're in a position to also start particularly looking at these specs for procurement purposes. So you're going to buy, first of all, everything you need from a long lead perspective, and then you're going to start going through and you're doing material takeoff of those schema and doing the procurement process so that you're getting everything queued up for the best price you can get it and the best schedule that you can get it. And of course, as you're locking that down, you're then able to do your detailed planning and scheduling for the capital project itself, taking you on through the construction phase, ultimately through completions, commissioning, and startup. And then having an incremental opportunistic handover to the O&M oriented systems, and having the feedback loops for continuous improvement, which are critically important as well, all the way out to end of life and remediation. So again, this is a true full life cycle view, and we're trying to support this again with the standards, with a digital ecosystem that supports this. Now let's take a look at the enterprise exchanges. And you notice I've highlighted here inter in the upper left-hand corner that are associated with things taking place across this life cycle. So in particular, this just looks at three types of industry participants that play roles across an asset life cycle. So this has got a single operator in the lower right-hand corner, a single EPC firm top center, and a single OEM on the left-hand side. And these are really common activities that are taking place as you look at the lines drawn back and forth between the networks here. And again, these take place whether they're done just verbally over a phone with paper-based documents, with spreadsheets, or now increasingly, we hope, with true digitally enabled approaches in digital transformation. So, but first thing is making sure that one does understand the nature of these activities that are taking place, and then one can create proper specifications for them wrapped around well-defined use cases that can actually turn into digital services specifications that work at this enterprise level. Now, if we take a look at a single node here, let's go to the owner operator because they would have a full stack. This becomes the enterprise specification. And the really handy thing about this is by having a shared spec between intra and enterprise, it allows things like this message service bus in the middle to be shared, okay? And then actually your individual use cases that have individual digital services associated with them, you can redirect through ecosystem administration on a case-by-case basis, whether or not a particular service is now being performed by someone in your enterprise, or is something now being performed by another firm that you've outsourced that work to. This becomes a very powerful set of capabilities then, because many people will mix and match throughout the life cycle of a business as well as the life cycle of an asset on what they're insourcing versus what they're outsourcing. So this was one of the really important things we wanted to establish, was the ability to span this, because the asset life cycle does in fact span it. So what you're going to see here, this is laid out against what's called Purdue Reference Architecture, or the ISA 95 model, which is an implementation thereof. This does include the the industrial Internet of Things devices. So you notice the extra I, it's not just IoT, it's industrial IoT. That includes the understanding of the greater levels of security that we have in the industrial world versus just a regular IoT device. And the key delineator there is if you have an area over here where we call it trusted systems, then that's probably an industrial IoT situation. This could be different specifications in the trusted system block depending on the industry sector that's involved. But obviously, in a lot of cases, this would automation and control environments that are real-time, near real-time, and actually have the capability to cause tremendous environmental or loss of life incidents if something actually were to go wrong there. So this dotted line is sort of a semi-permeable membrane, giving extra protection in that area. You notice these are dotted lines in and out as well. And for a device to work, it's got to come up here, get permissions, and then go back down. And then these are the enterprise connections. So this all actually works quite well in a cloud-oriented environment. And that's the way a lot of this is being implemented, certainly at every level above here. And now there's even some cloud level implementations of automation and control, although that's typically local cloud. Another view of that, so this is the same basic model, is taking a look at what's going on. And this is where you have OPAS that many of you may be familiar with, the work that's going on here to basically standardize the work around the DCS systems. This is that trusted system block. Everything else is the same here in terms of how things fit together with each other. How are these use cases built? Okay, so again, these are what are called fully dressed use cases. They're carried out to a great level of detail. They take us from a really high level user story that's told with pictograms or whatever can be understood by the people that understand the functional requirements and business requirements. And then that actually gets carried over to formalizing out the use cases, now starting language being used by IS professionals and systems analysts in particular. Those are decomposed into reusable scenarios, and they're further decomposed into reusable events. This starts to give a particularly powerful combination where you could think of these as being like individual Lego blocks. These are combinations of Lego blocks that are used over and over and over again. And this is a top level combination of Lego blocks that supports an entire use case. So we get this idea again of modular and reusable specifications for modular and reusable code. By the time you're down at an event level, you actually are dealing with the details for the standard APIs, the standard data models, the standard data containers that allow you to have exactly what a coder needs to actually provide an implementation of things that will interoperate with each other. Again, that gets wrapped on up going through this process. So we go from the really high level stuff right down to that lowest level. Pragmatic standardization process. Again, to build these things up, there has to be a process-oriented way of getting there. So there are a whole series of published OII use cases that started out, and many of them you can see on the operations and maintenance side of things. These are increasingly coming over to the side dealing with the capital projects. And this is where, by working with that community, particular Construction Industry Institute, as well as others, we're able to establish what the best practices are there. And then say we're now in a digitally transformed world where there are digital twins being built over here in a digital ecosystem that's neutral, that will, again, start with engineering twins and design twins, and then as built twins. And those twins can ultimately be leveraged as we move into operations and maintenance. And we have the as maintained twins as well, and everything can be kept synchronized this way. So this is getting us to this supplier neutral digital handover and doing it in a way that actually can help the people in the capital project community do a better, more efficient job. At the same time, it's going to give what we need in the O&M world, everything for a really graceful handover, all based on standards that are supplier neutral. This has been a long-term objective, and it's starting to be realized now with increasing levels of detail and capability as we move into certainly next year. So I described earlier the pilot, mostly verbally. So this is another way of viewing, what does the program itself look like, the R&D program, which features the pilot. Again, I've already said we're capturing requirements here. We've got the, standard, the ISO level standard and the industry level standard that both come out of this process. And again, it's a digital ecosystem that we're building with digital twins and standard digital services definitions that help us have systems of systems interoperability. And it's leveraging all the key bits as well out of AI and ontology and things like open technical dictionaries. So it's federating standards that exist in a consistent, repeatable, scalable way. And ultimately, what we're winding up with, again, is this is sort of the list view. You have the standard use cases, scenarios, and events, which really are standard digital services definitions, the standard APIs, the registers and services directories, the models, the message models, reference data. And that allows standard adapters to be built, which means you can now link in pre-existing commercial off-the-shelf or custom-built applications and systems so that they're all speaking the same language, hooking up the same way with each other. 100,000-foot snapshot of what does this process look like? Again, capturing requirements down here from the industry, putting priorities on them in conjunction with our members and our industry sponsors and pilot sponsors. And then we have moving into the pilot phase. We wind up iterating around and around in the pilot. And when we think something gets good enough from piloting that we're going to lock down a version managed standard or specification, we do two things with it. We scale it on up to say at the industry level, we can now start doing industry level implementations thereof. We can also generate then the official ISO technical report that's the input vehicle out of this into ISO, which then goes ahead and winds up defining a future TS or multiple future TSs that contain these use cases at the same time that we're driving out some of the other specifications. And this scales right on up then to how do people implement this and actually realize business value in the real world with their enterprise scale or inter-enterprise activities, and scaling right on down to the relatively small elements thereof in a system of systems model. So again, there is a feedback loop for continuous improvement here, but ultimately, like I said, it's a fairly well laid out process. We've been doing this for a while on iterating on it. We're currently in phase 3.3, and we're actually getting ready to move to phase 3.4 before the end of this year. If I take a look at that in a little more detail, we run the development process and the pilot in an agile manner. So, we try to realize that we're not going to know everything about everything when we start on things. We keep iterating in sprints as we build the specifications up. And again, a lot of this is capturing requirements, making sure we got them captured and documented correctly. And then how do you actually validate that you're doing that correctly? Well, okay, this is where the piloting process kicks in to back this up. So now you've got the wheel within a wheel here, if you will. So we're building out the use cases, and then we're validating them as we come through in the piloting process. And ultimately, again, when we reach the point that we think we're good enough, that we're going to put a industry standard version number on there and start actually using it in maybe first an internal pre-production pilot and then right on into production. This is also where we would spin off to ISO 18101. What are we doing in 3.3? This is a quick snapshot. So again, we have these sets of pre-existing use cases. In particular, in 3.3, we focused in on 3 pre-existing ones that are in the capital project and the addition of a new one around purchasing, so that we're filling in these gaps in the capital project that are allowing us to, again, build up our as designed, and then in this case, through the procurement process, get all the additional stuff we need for planning and scheduling so we can get to then our as builts. So this is being done again as we speak during the course of this month, and there'll be a video made of this working together on a seamless end-to-end basis. In this case, we're actually passing over to SAP. This could be some other product. We don't care. We always work supplier agnostic. We've done this previously with the other major suppliers of CMMS or plant maintenance, in this case, systems. So that's a key thing. Everything we do must in fact be supplier neutral and standardized. But yes, we do work with the tangible systems from the tangible suppliers to make sure that this works correctly with them. And where at all possible, we have those suppliers work together with us to support the overall activity. This is just a textual layout for the very same thing that you just looked at, but this is also showing what happened in 3.1 and 3.2 at a really super summary level. And then the ongoing work, again, is taking place right now This also did include some of the initial work that we've been doing with the IOGP, CFOS organization, their reference data library, as well as with Construction Industry Institute, and some of the initial work that we're starting to be able to include related to IWPs. And then also with our OIA Australia working group, where we have a relatively large team working on things together with each other all the time. And that's really allowing us to build up the portfolio of different industry groups sharing their requirements with each other. And again, using MIMOSA as a safe harbor for doing that to keep building ever more realistic approaches in the pilot, at which point people can say, that's good enough. It may not be perfect yet, but it's better than what I've got already. That's good enough. I can start to, use that process I was showing a bit earlier to say, I'm going to move this into, again, some sort of pre-production pilot and then scale on up to production. Phase 3.4, we're getting ready to get started again by Q4. This is wrapping up. We hope by the end of this month, it might spill a little bit into November. We'll be picking up with Q4 pretty much hard on its heels, because we've got a whole group of people now telling us what they think is important and priorities. And we actually have, again, as I'm going to show in a minute, quite a few groups cooperating and collaborating with each other to allow this work to be done at increasing levels of detail. And in particular, again, I'm going to mention something about this Future Energy Exports Cooperative Research Center. This is something we're leveraging heavily because it means that when we put our hard-earned R&D funds in, we actually are able to get matching funds from the Australian government to, again, move this forward. And that's something, again, it's a benefit of working with a standards organization like MIMOSA, where we are working internationally, and we're aware of when people set vehicles up to actually try to help accelerate these sorts of processes and make sure that we can get economic efficiency for everything we're doing in R&D. So again, it's a shared cost, shared risk sort of model on a high percentage of the work that would otherwise be done in silos and not really help us solve the problems that we're facing right now. So I mentioned, again, many collaborations. All right, so I'm going to start at the lower left, right down here. Again, I was just mentioning this Future Energy Exports Cooperative Research Center. That is formed, again, it's a 10-year project that's laid out, or 10-year program that's laid out. There's a whole series of embedded projects. The members determine, what those projects are and what their priority are. There are members there from Australia, Japan, Korea, and the US. So, some of the names you guys would recognize from the US side, Chevron is a for instance. And then, on the Australia side, there's a number of large Australian operators. There's Japan has their national oil company, INPEX, is involved, and their suppliers, again, as well as a lot of academic members in these university-based research centers, actually all working together. And this is something that, again, we put a lot of emphasis on, because that approach allows us to truly stay supplier neutral, having the university-based research centers, but also having the work really driven by the practical and pragmatic industry requirements. So it's, not just pure research. It's not even just traditional applied research. It's applied research very specifically to solve really well identified problems coming from industry on a timely basis. The work I mentioned previously, we have an MOU with IOGP, that's International Oil and Gas Producers Association. They have a couple of groups, in particular CFOS, that we're working with, where they're also producing handover specifications that we are then using along with reference data that they're building out, that we're starting to demonstrate the use of that together in our phase 3.3 pilot and beyond. I've also mentioned Construction Industry Institute a couple of times. So again, we have a joint working group with them framed up by an MOU. This is where we're really focusing very much on construction industry work, obviously in the capital project side. And then we're looking at, again, things like advanced work packaging that they've sort of led the world in trying to develop that and get it well documented. We've got, again, ongoing work there that's iterating where preliminary outputs are being shown in phase 3.3. The OIIE O&M working group, that's really the Open O&M initiative. So that's particularly those of us who are working together between the operations management world and the maintenance and reliability world for lifecycle asset management. Then when we include the capital project stuff, we have our own capital project working group that also is picking up the whole capital project, including the handover and looking at that in an integrated way. And then we have a standalone Australia working group because we have so much activity going on down there between, again, multiple universities, multiple operators, multiple suppliers, that's turned into a really nice crucible, if you will, to try to develop a lot of this work and move it forward on an expedited basis. All right, so again, if you've looked at this, you're interested, do you think it may help you solve some of your problems? Then the next question is, how would you actually get involved in it? And this is from both a use point of view as well as potentially a development point of view. So again, all of these standards and specifications allow you to make the decision. Do you want to use something perhaps built by a third party as a commercial off-the-shelf offering, contract with a third party to build your own implementation thereof, if that's what you prefer, or if you actually have an internal development staff and they want to build their own, all three are possible, and they can actually all be done in combination with each other so that you could use commercial off the shelf for the things where they exist and you like the approach, or do it yourself or ask someone else to do it for you when you get into areas that maybe have not been addressed with a commercial off the shelf implementation thereof yet. So this breaks this down. There are 3 workshops that have already been scheduled into these various areas that people have to understand in order to build and use at a detailed level. The 4th workshop is not scheduled yet, but it's the final set of that work. We're thinking it'll actually be early February next year, but the combination of these will be reusable as individual workshops with the documents being published and shared, a Vimeo being published and shared, and then we would set up Q&A sessions for individual groups that would work with us in advance to let us know they need to do that. And so last, there are many websites associated with this. The 2 I'm going to direct you to here, MIMOSA, mimosa.org, and OpenONM.org. Virtually all the details for all the work that's going on are actually there. The only thing that's not there are some of the work in progress detail specifications that for intellectual property purposes, we have to keep for people who are in fact signing at least the IP rights agreement so that we actually have safe IP for everybody to use. And I thank you very much for listening. I hope this has been useful, and happy to take questions now.
Alan, great job. We appreciate your expertise and the presentation. We have time for a few questions. So let's get right to it. A few reminders about the course while we get ready for answering some of the questions. Just check on the screen here. Also, if you need the continuing education credit, please pass the final exam at the end of this session, and then on to the questions. So past standards often didn't result in interoperability, and we talked a lot about that in this presentation. What are a few ways that these standards are hoped to be different?
Well, okay, it starts off with the actual reason that you're building the standard from the outset. So if you're developing a standard to aid interoperability, you may approach it slightly differently than if you're only trying to do concepts. So the standards and specifications included in the OIIE 18101 are in fact specifically designed to help achieve standards-based interoperability. We build on top of and reuse the standards that only identified the concepts. Then we add the remaining details required for interoperability in known, standardized, fully dressed use cases. and we use the standardized use case architecture and the R&D methodologies. So rather than boil the ocean as well, which that's one of the reasons standards sometimes stop at just concepts, this lets us focus on specific use cases and then build larger and larger collections of them. The use cases share the primary components that are designed for interoperability purposes. And again, this has the standard APIs, protocols, directories, registers, and message models, as well as data models that are used on a repeatable and scalable way. And also by our initial focus in asset lifecycle management, it really helped that all the operators said they agreed that they didn't compete with each other in that space. So it gave us a good, safe place to start.
I'm glad you've gotten to the point of pilot projects. Will the pilots influence future iterations of the standards, or are the standards likely to stay as they are for some time?
No, we anticipate this space being pretty dynamic. That I mentioned, we operate in an agile fashion. And even once we get to the ISO level, yes, we expect things to change pretty quickly, which is the reason we're not even trying for ISs right now. We're just doing TSs that we would update every 3 years. So our methodology, again, through the pilot, means we're constantly going back and collecting new requirements. And then we work with our members and the sponsors to say, what are the priorities on those? And as those bubble to the top, then they're used to drive out the next updates or creations in an iterative manner. So we think this is a very dynamic way to sort of help people really close the gaps and meet their requirements.
Great, thanks. Could you offer some practical advice for engineers involved in maintenance? I mean, there's a lot of people involved. Maybe go over who you envision the advice being for.
Yeah, so this is a very interdisciplinary effort by necessity. And again, that's probably our realization of that maybe is another distinction between what we have to do for interoperability and a lot of other groups who do their best, but they work in silos with people like themselves. So in this case, it's certainly the engineers that are, often in maintenance, but could be maintenance and reliability management in particular, which is somewhat broader. But then it's also the ISIM and IT support staffs that actually need to help them. In a lot of cases, make sure that they can implement these things in the environments that they have. So the engineers actually are going to always have to provide the functional requirements. What is it they need to do? And then if they can use our process to help lay those out in a very commonly understood way, we can get the specifications done so that their ISIM and IT support staffs also understand in the language that hopefully makes sense to them.
Yes, the language is very important. So you mentioned O&M and ISA involvement. How is the work related to operations management? Last question.
Okay. Yeah. So again, by working from the very beginning with ISA in particular on this and the ISA 95 committee, we always envisioned that we would be bringing together operations and maintenance at a bare minimum. And we more recently then added the full life cycle through the capital project into the thing. So what's important, I think, here is to know that the ISA 95 committee is committed and continuing to work on this with us. I'm a voting member there myself, but we have now strong support from the chair as well as the editor and ISA itself. So that in addition to these asset lifecycle use cases, as we go into 2022, you're going to start to see operations management use cases actually also added into this very same portfolio. So they will also sit in the ecosystem and be able to be full partners in the effort, which is what we really need.
Many thanks to Alan T. Johnston, MIMOSA President and Convenor of ISO TC 184 Working Group 6, Interoperability for Asset-Intensive Industries. I'm your moderator, Mark T. Hosky, Content Manager, CFE Media and Technology. Thank you for joining us for this session, Standards-Based Interoperability for Digital Transformation and Asset Lifecycle Management.